Algebra 2 Honors, 12.2 Permutations and Combinations. So we've done a fair amount of algebra now. So we're going to, of probability now, we're going to take it up a notch. We have 4 applicants for the positions of salesperson and cashier. So here's salesperson and cashier. So we could have AB, AC, AD. Could also have BA. And this is one of the tricky parts of algebra. We ask ourselves, are these, probability, are these the same? Well, in this case, no, they are not. The salesperson is one person and the cashier is another. They have different skills, so they're not going to be able to do the same thing. So if that's the case, then we have to go BC, BD, CA, CB, CD, DA, DB, DC. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 different ways. So it's a permutation. Most important thing to remember is in a permutation, order matters. It matters if I have a salesperson before a cashier. If I was just getting 2 people to be salespersons, then it wouldn't matter. And we'll cover that in a little bit. It's called a combination. So here's the formula for it. What it means is the first number goes on top, 10 factorial, and then we subtract 10 minus 6 factorial. So it's 10 times 9 times all the way down to 1. 10 minus 6 is 4, so 4 times 3 times 2 times 1. Well, most of this cancels out. We're left with 10 times 9 times 8 times 7 times 6 times 5. And we figure that out using our calculators. $151,200. So you can try the other 2 if you want, because now I'm going to do them. 6 permutation, and there's a handy button under the math for this on your TI calculator, is 30. And here is just 5 factorial over 5 minus 5 factorial, which is 5 factorial over 0 factorial, which is 5 factorial, which is 120. So watch out for that. So let's try the area code. Now, there's 2 ways to do the area code. We can say there's 3 digits, and we cannot repeat a number, so order actually matters now. 10 for the first, can't repeat it, times 9 times 8 is 720. Well, now with the new information we have, we can do it differently. We can say it's a permutation because order matters. It's a dependent event, and we're choosing 3 out of 10. If you put that in your calculator, you get 10 times 9 times 8 times 7 times everything. Over 10 minus 3 is 7 times 6 times everything, and everything down here cancels. 10 times 9 times 8 is also 720. It's kind of nice to have 2 different ways to do a problem, so if you make a mistake. Now here's another one, different problem, similar concepts. We count the letters in the word Mississippi. How many ways can we rearrange it? I got 11 letters, so 11 factorial. But we have 1, 2, 3, 4 I's, so we have to divide out 4 factorial. 1, 2, 3, 4 S's and 2 P's. So that gets a little bit difficult if you don't remember it. I've done a pretty reasonable job so far of making sure I show you where all this information comes from. In this case, you're just going to have to take my word for it. We could actually model it, not with Mississippi, that would take forever, but you have to just believe me. So you could try it with a word like school. You would say that's 6 factorial over 2 factorial, which is 360 ways. You could actually sit down and start playing with this and see how many different ways you could arrange them if you have some free time on your hands. What if order doesn't matter? And I actually like to jump down here. We've got pizza and we're going to put 6 toppings on. Does order matter? We're only going to put 2 pizza toppings on. We have 6 to choose from. So sausage, pepperoni, mushroom, olives, bacon, and green peppers. So sausage, pepperoni, sausage, mushroom. Here's the argument. Are these the same or are they different? Well, in this case, I've set them up so that they are the same. If I throw the pepperoni on and then the sausage, or the sausage and pepperoni, it's not going to matter. So now I cannot make as many combinations, for lack of a simple way to put it. And that goes for everything down the line. I can only use the ones beneath it. Mushrooms, olives, bacons, and green peppers. Bacon and green peppers. Olive and bacon. Olive and green peppers. And then just bacon and green peppers. Gives me 15 ways to do it. So it's a combination. Combination C6-2. Looks just like the other one. 6 factorial on top, 6 minus 2 factorial, but we also put 2 factorial there. We'll end up with 6 times 5 over 2, which is 15. Same thing we got down here. C6, try 10C6 and C55. Should get 210. 5C5 should get 1. And if you think about that, I have 5 people. And I'm choosing 5 people, and I don't care what order I get them. Well, there's only really one way to do that. Just give me 5 people. I don't care. A great example for a combination. How do we figure out how many different ways we can pick 3 people for student council? Well, this is the key. It's a council. We don't care first, second, or third. So order does not matter. So we're picking from 10 people. It's a combination. And we're picking 3 people. Do that, and you should get 120 different ways. Deck of cards is actually quite a challenging problem. 5 cards are drawn from a standard deck of cards. 3 clubs and 2 diamonds. How many are we picking from? 13 clubs. And we're picking 3 of them. 13 diamonds, and we're picking 2 of them. This is confusing to a lot of people, but don't worry. We'll show you this in much more detail in the next unit, which is probability. Multiply them together, you get 22,308. So that's 22,000 hands with 3 clubs and 2 diamonds. So that's it. Give it a shot, see where it takes you. And as always, happy mathing.